Okay, so a deep dive follow-up to last week's video on porting Commander Keen to the web browser. I'm going to do a deep dive on how to set up your dev environment and how I ported Keen to run in the web browser. I'm going to do all this from scratch so you can follow along and hopefully learn something about WebAssembly along the way. As a quick recap, I used Emscripten to compile this chocolate Keen source code to WebAssembly. And then with that compiled to WebAssembly, we were able to then run Keen in the browser. And it works really well. In terms of dev environment, I'm using Windows 11. For the command line, I'm using WSL, or the Windows subsystem for Linux. And for IDE, I'm using Visual Studio Code. So this is Linux on Windows, but these steps should work with any standard Linux distro as well. The first step is to download the Chocolate Keen source code, which I can find here. I'm going to extract it. And then I'm going to copy this source to my Linux environment. I'll just put it in the home directory. So a quick check. And there we go. We can see it in the home directory here. With the source code downloaded, we need to make sure it actually works. So the first thing I need to do is install some Linux build tools. So first, I'll install Build Essentials. And then secondly, I'll install SDL. This is the dev library that Chocolate Keen uses. With these installed, we should be able to build and run the source code. Let's take a look now. Okay, a few errors, but the build completed successfully. And if we take a look, we now have a Chocolate Keen executable. So let's try and run that. Okay, that works pretty well, but this isn't WebAssembly. This is a regular GCC build on Linux. But now we've proven that the code works natively, it's time for WebAssembly. So we need Emscripten. That's the WebAssembly compiler. So I'll put these two windows side by side and we can follow the Emscripten install instructions. First, we need to get the Emscripten repo. Then navigate into the Emscripten directory. We install the latest. And then we activate the latest. With that done, we want to add the Emscripten commands to our path. So to do that, we run source emsdk env.sh. Done. With that in place, we'll head back to our Chocolate Keen source code and we'll open up Visual Studio. We need to update our Makefile to make it work with Emscripten. As a first step, let's change our compiler to EMCC, the Emscripten compiler. We'll save that and now try to build our code. Okay, so that failed. And the reason for this is Emscripten needs its own version of SDL. So let's head back to our Makefile and find the compiler and linker flags. Okay, here they are. So we'll comment these out and we'll replace them with new commands for Emscripten. We'll tell the compiler to use port equals SDL2. This is the built-in Emscripten version of SDL. Lastly, we'll update our executable path to be HTML because we're building for web, not native. So let's save and then make again. Okay, so you can see we now have WebAssembly, JavaScript, and an HTML file. This is looking pretty good. Next, we need to mount and run these in the browser. So we'll use this mini Python web server. Okay, so it freezes. And if we bring up Task Manager, we can see that one of our processes down here is being hammered. So we're stuck in an infinite loop. So the question is, why does this happen? And the realization is that WebAssembly does not work the same as a native environment. In a native environment, we can have an infinite loop, and the system will still find time to be able to render frames to the screen and read input, because that happens with hardware in parallel. In WebAssembly, we, the programmer, need to return control back to the browser so it can do those things, so it can draw the frames and it can read the input. Otherwise, we just get stuck in this loop and the browser, as we can see here, appears to freeze. And the way that we're going to do that is with Asyncify. As it says here, Asyncify automatically transforms our compiled code into a form that can be paused and resumed. And it handles the pausing and resuming for us so that it's asynchronous, even though the code is actually synchronous. So the way we use it is with this linker flag. So again, let's put the browser side by side with VS Code. And we'll specify -s Asyncify. Save. Back to Linux. We'll clean and then build again. We'll run this new code and hope for a better result this time. Okay, that's better. Now the code's running, it's responsive, but it can't find the level data. So now we need to look at packaging. So the realization here is our program doesn't know it's running in WebAssembly. It thinks it's running on a regular PC, and it's trying to load its files from the C drive. We need to package the level data and create a virtual file system for our WebAssembly program to load the levels. And we'll do it with this preload file command. So let's copy that and back to Visual Studio. Scrolling down, we'll paste in here. And we'll update the path to our game data path. Save again. And then build again. Let's give this a try. Okay. So we are looking good. I'll exit full screen to prove we're actually running in a browser and zoom out a bit. Here we go. That's how you do it. So how'd you like this unscripted video? Do you like the deep dive format? Was it interesting? Let me know in the comments below. Enjoy!